Morning. We are going to solve the example on friction from Unit 2 of Engineering Mechanics. So here, a block mass is given. The question is for 7 marks. The mass of the block is given 10 kg. Then, it is placed on incline the block. If the coefficient of static friction, that means nearness, is given, coefficient of static friction is 0.25. These are things are given. Mass is given 10 kg. Coefficient of friction is given 0.25. What they want to find out the P as the force required to keep this object in equilibrium. P, that is a force required to keep this object in equilibrium. So now what we are going to do here, this angle is also given, angle of repose is also given, that is 30 degree. Angle of repose is given. Again, as this is a friction problem, we have to draw the FBD first. P is given like this. P is pulling this block upward. Okay, P is pulling this block. This is the given data in the problem. So what we are going to do? First we have to draw the axes. As I explained in the classroom that whenever the slanting surface is there, please consider the slanting reference axis. A parallel to plane of the slanting the x-axis and the perpendicular to this is what? Y-axis. This is done. Now, we have to use different colors so that you can identify. Now, I know that normal reaction is always perpendicular to the surface. Surface is slanting, so normal reaction is perpendicular to the surface. So, it is denoted by NR. NR stands for normal reaction. Normal reaction. Okay, now this is the angle of repose. Weight is always acting downward. Weight, you very well known what is weight. This is a mass 10 kg. I am going to convert it into weight 9.10 into 9.81. Now this angle is nothing but 30 degree angle of repose. Again I am going to resolve this weight. Which one is 9.81. 10 into 9.81. What it means? 98.1. Okay. This means this is what actually 98.1. 98.1. So I am going to resolve it. This component, the angle with whom? Y. So Y component is cos 30. And this is what? Sine component, which one is 98.1 sine 30. Resolve. After that, I know P is exactly here. P is exactly lying on this X. No need to resolve this P. P as it is. Any more force is remaining to show in FBD? Yes. Friction force, as we are studying the friction. So friction force is remaining here. So as you know that this block will pull, the motion of the block is upward. Motion of the block is upward. So as you know that the friction is always in the opposite direction. So it is in the opposite direction, friction downward. You can show anywhere along this plane. So I am going to show here Fr. Friction force. Fr stands for friction force, which is always opposite in the direction of motion. Motion of the block is upward, so friction force is downward. The formula of friction force. The formula of friction force is μs into Fr. Now we have to apply the conditions of equilibrium. This is a given data FBD. This completes your first step FBD. Correct FBD carry 2 marks, and which is very important because all the equations are based on the correct FBD. Now I am going to apply the equilibrium conditions as I want this block is in equilibrium. So I am going to apply the equilibrium condition. There are two conditions you can apply equilibrium, because if I want this block is in equilibrium, all forces sum must be 0. So I am doing the summation. What stands for Fi? Sum of all vertical or y component. Y component. Okay. Now components. Whatever the components here, how many vertical components are here? One is NR, another is 98.30. These two components are vertical. So I am doing, as you know that, please remember or write down somewhere. If arrow is upward, so plus, along y. If arrow is downward, so minus. If arrow along y, if arrow is towards x negative, then it is negative, towards y x positive, then it is positive. So now as NR is upward, so NR is plus, and this 98.1 cos 30 is downward, so minus equals to 0. So from this equation I can easily find out the NR is 98 cos 30. So 98.1 cos 30, the answer is 84.957. Okay, and this is, if you take this value this side and RHS, then the value is what? Positive Newton. Okay, now we have to find out the P. For that I am going to use the second equilibrium condition, Fx equals to 0. What are the sum of horizontal forces? Sum of horizontal forces is what? How many horizontal forces in this case? One is friction force, another is 98.1 sine, and one is P. Three forces are there. Friction force, 98.1 sine 30, and the P. So friction force is towards negative axis, so I am writing Fr. P is toward plus, so I am writing P. And 98.1 component of the weight towards negative sine 30 equals to 0. Friction force, I know the formula, I am putting this value here. What is that friction force? What is the coefficient of friction? 0.25. NR I got in the first step only. So NR value is 84.95. So friction force is what? 0.25 into 84.957. At least take after the decimal 3 digits are there. The answer is 21.239. So I am using this friction force 21.239 plus, I don't know the P, and 98.1 sine 30, keep as it is. Do this calculation in calculator. Don't waste your time doing the calculation. Okay, too fast. Minus 90 minus 21.339 minus 91 sine 30 equals to 70. So it's a minus 70 actually, but when we move from the LHS to RHS or RHS to LHS, the sign going to change. So answer is 289 Newton. So dear, this is the steps to complete your problem when they ask to find out the force P. The question is what? What is the force required to keep this object is in equilibrium, this block is in equilibrium? That force we got the value P equals to 70.281. So in this way you can solve the block friction problem. Thank you.